Hello everybody, this is your old buddy Bill. I don't know nothing, I'm just a country boy. Anyway, I just want to tell you about parametric oscillation and what actually happens with parametric oscillation. One of the phenomenons that keep a lot of engineers and PhDs and all the guys that think they know something, what keeps the phenomenon from happening are these little guys right here, gauges. And anyway, the one of the things that gauges do, they draw current and they screw things up at the wrong time to get into parametric oscillation. To find parametric oscillation, I can guarantee you that before it goes into parametric oscillation, you won't discover the secret to it if you have a meter on it. And then the problem is, once you get a damn meter on it, when it's in parametric oscillation, you got more damn current than your meter can handle. And it's an amazing thing. And all I have there is the configuration that would be seen by the Bedini coil and the Bedini wheel if that's put in there. I can also tell you, if you put a damn light bulb in the circuit before it goes into parametric oscillation, guess what? It won't go into parametric oscillation. And then, to add insult to injury, if you put your protector in there, you can go into parametric oscillation. However, if the resistance is too high and that sucker starts protecting and you don't have the balance on your batteries, guess what? You're going to burn your transistor up. And that's just the way of life. It happens. But there's one of the secrets to finding parametric oscillation is understanding that if you put a meter on it when it's happening, any kind of meter, you're not going to get there. Okay? So I'm going to give you that tip. Anyway, whatever you do, this bulb right here, to go into parametric oscillation, it can't be there. Okay, that 3 watts will keep it from going in to parametric oscillation. Basically, the energy that I found that this puts off is exactly what the magic monkey is, and that's the reason of the secret of it, is because it resonates when it goes into parametric oscillation at about 7 hertz, 7 to 12 hertz, depending on your asymmetrical circuit. This is an asymmetrical circuit, and the base and the emitter divide those voltages. And so if you have two 12-volt batteries on there, you have 24 volts in the system. And so you have 24 volts here. I mean, you have 12 volts here, and you have 12 volts here. Okay? And then when you slide on up to 24 volts, there's weird stuff that happens. If you have a meter on there, the phenomenon will not happen. Okay? Because what happens is this becomes the neutral in the triangle. It's a triangle just like this is a triangle. And I believe that when you balance that triangle out in that waveform, that it works just like the PMH. When you do a magnetic lock on the Planck level, in the microscopic level, on the atomic level, that magnetic bubble is resonating on such a small scale, but it's got a lever in that triangle that can move the whole world. And once you understand how much energy you actually have there, it's very, very easy. But you're ringing the bell twice in the triangular circle, and the when you get it going right, this end battery, you've got all kinds of power. Okay, doing parametric energy is easy. My problem is that I'm dealing with high horsepower equipment, and I don't want to go through like they do with forklifts using big resistor banks and big capacitor banks. So I'm working with a special emulated spark gap system because I can't have with the fuels that the pumps will be going into this spark gap that's happening right here in the variable resistor. I have to emulate that spark gap a different way, and that's the reason I've been working with weird frequencies. Okay, I'm dephasing that magnetic pulse with high frequency, and then I'm figured out a way to return it back, and that's the what's really proprietary. This part of the parametric oscillation has been going on for a long time, and I'm just going to give you a heads up with it that if you put a meter on it before it happens, you're screwing up the process, because what happens in that triangle, this is your neutral. Okay? That's your neutral. One side's going to have the high potential negative, and the other side's going to have the high potential positive. And believe it or not, it can swap depending on how it's isolated. So I'm going to give you that real short and sweet tip there, and because a lot of people go through a lot of frustrations. I'm going to tell you that your magnetic core, your inductor, to get parametric oscillation, you've got to train it. It'll self-train under the right conditions, and when you get it right, and that's the reason I was able to get parametric oscillation with that. So anyway, I hope you're having a good evening, and keep working hard at it, but I do want to give you the secrets of parametric oscillation. And basically you got 12 volts coming through, but you have a triangle, and you can extend that triangle on out to 48 volts and right on down the line, but you have to be careful what you're doing. When you get up to 48, you're really getting your horsepower up there. I mean, you know, the meters, you know, it's easy for me to peg out that meter with 80 DC amps. Okay, so you're getting into a thing that can melt a crescent wrench right there before your eyes. I mean, it's amazing. So that's the reason a lot of people have such a hard time sharing this information. With this particular group, I do want to share it, and I do want to, you to understand what's going on. But it's, you put a meter on it before parametric oscillation, it's not going to happen for you. So y'all have a blessed day. Please be safe, and love you guys.